This is General Chemistry, cover the topic of gas, part 9. Today we will be looking at collecting gas over water. Collecting gas over water is pretty much a continuation from gas reaction and stoichiometry that we talked about in the last video. But this time we will be a little more specific. We will look only at reactions that produce certain type of gases, for example, hydrogen or oxygen gas. Let's say we have an experimental setup here. The round bottom flask on the left contains a reaction mixture. The gas generated by the reaction can pass through the green tubing into the water bath and get collected inside the flask on the right. Since the gas has to bubble through water into the flask, this setup is good for gas that does not react with water and gas that is not readily soluble in water, for example, hydrogen or oxygen gas. But for gas that are more soluble in water, for example, ammonia gas or sulfur dioxide, this setup is not good to collect such gases. For the flask on the right, initially it was completely filled with water. But once the gas from the reaction is bubbled through, the gas will displace the water and will be collected over water inside the flask. So inside here, there are at least two types of gas. First is the gas generated by the reaction, and second is the gas from water vapor. So based on the partial pressure concept that we talked about previously, we can say that the total pressure inside that flask is equal to the pressure of gas generated by the reaction plus the pressure from water vapor, or P total equal to P gas plus PH2O. Let's take a look a little bit at the last component in this reaction, PH2O, or the pressure from water vapor. It's worth noting that water vapor pressure depends on the temperature. As you can see from these values here, when the temperature increases, water vapor pressure increases too. So those are the key concepts. Now we can take a look at some practice questions. For the first one, reaction of magnesium metal with hydrochloric acid release hydrogen gas, and the reaction is given here. The hydrogen gas produced is collected by displacement of water at 20 Celsius. The gas occupies 250 milliliter and the total pressure is 765 millimeter of mercury. Calculate the mass of the hydrogen gas obtained from this reaction. If you notice displacement of water by gas or collecting gas over water, it is most likely that we're going to be using P total equal to pressure of gas plus pressure of water. And let's take a look at what they give us here. They give us total pressure, which is 765 mmHg, and they give us water vapor pressure, which is 17.54 mmHg. Now we can plug it in. So P total is 765 mmHg equal to P of hydrogen gas plus P of water vapor pressure, which is 17.54. So P of hydrogen gas gonna be equal to 765 minus 17.54, and we're gonna get 747.46 mmHg. But we know that the unit of gas is usually ATM, so we can convert that into ATM. And this is the conversion. 1 ATM equal to 760 mmHg, and that should give us 0.9835 atm. Now we can follow the same steps we normally use in the gas reactions. And the first step is to check whether the reaction is really balanced. And the second step is to find the involving species and connect them by using mole. Alright, let's try that. So for the first step, we write down the reaction here. Magnesium plus 2HCl give MgCl2 plus H2. So normally a way to do it is to list all the elements on the left and also the same elements on the right. And we can see that on the left we have 1 magnesium, 2 hydrogen and 2 choline. And on the right we have 1 magnesium from magnesium chloride, 2 hydrogen from hydrogen gas, and 2 choline from magnesium chloride. So all the elements match. So this one is balanced. The second step is to find the involving species and use mole. To find the involving species, we can look back into the question. The information that they give us is the volume of the hydrogen gas. And they ask for the mass of hydrogen gas. So the only involving species here is hydrogen gas. That makes life a little bit easier. Since they give us the volume here to 50 milliliter, so it's most likely that we're going to be using PV equal to nRT to obtain the mole. So let's write it down. PV equal to nRT. N equal to PV over RT. P we obtained it from earlier and it is 0.9835 atm. And V is 250 milliliter, which can be converted to 0.25 liter. And R is 0.082 liter atm per mole Kelvin. And T is 20 degrees Celsius, which is 293 Kelvin. And we should get about 0.010 mole for mole of hydrogen gas. Alright. But they asked for the mass of the hydrogen gas. So we have one more step to do. To relate the mole to mass, we can use mole equal to mass in gram over molecular weight or molar mass in gram per mole. And that means mass in grams gonna be equal to mole times molecular weight. And it is 0.010 mole. And the molecular weight of the hydrogen is 2 gram per mole. So we're gonna get 0.020 gram as the mass of hydrogen. Alright, and that is the answer. Let's try the next question. For this one, thermal decomposition of potassium chlorate yields oxygen gas, and the oxygen gas generated from 2.5 grams of potassium chlorate is collected over water at 27 Celsius. The total pressure is 762 mmHg. What is the volume in liter of the oxygen gas, and the water vapor pressure at 27 Celsius is 26.7 millimeter of mercury. Since we see the word collected over water, most likely we're gonna be using P total equal to P gas plus P water, and we can plug it in. P total is 762 mmHg, and P gas is P oxygen, and P water is 26.7 mmHg. So P of oxygen is gonna be equal to 762 minus 26.7, and that's gonna give us 735.3 mmHg. And to convert that to ATM, we can write down 1 ATM over 760 mmHg, and that should give us 0.9675 ATM. And now we can follow the step of the gas reactions. First, we have to check that the reaction is really balanced. KClO3 to 2 of the KCl and 3 of O2. In this case, it is really balanced, but I will leave it to you to check it. And the second step is to look for the involving species and link them using mole. The questions give us 2.5 grams of potassium chlorate and ask for the volume in liter of the oxygen gas. So that means the two involving species are potassium chlorate and oxygen gas. To convert the mass of potassium chlorate into mole, we can use N equal to little m over big M, and little m is mass, which is 2.50 gram, and big M is the molecular weight in gram per mole, and we're gonna calculate that in a bit. So for potassium chlorate, for potassium is 39, plus for chlorine is 35.5, plus for oxygen is 16 times 3, and that's gonna give us 122.5 gram per mole. So we can plug that in here, 122.5 gram per mole, and that's gonna give us 0.02 mole, and that's the mole for potassium chlorate. But the species we're looking for is oxygen, so we can set this 3 of oxygen over 2 of potassium chlorate. This actually from the reaction gonna be equal to mole of oxygen over mole of potassium chlorate, which is 0.02 mole. So mole of oxygen gonna be equal to 0.02 times 3 over 2, and it's gonna be 0.03 mole. Alright. But the question asks for the volume in liter for the oxygen gas, so we have one more step to do. To convert the mole of oxygen gas into liter or volume, we can use PV equal to nRT. And the volume that we are looking for gonna be equal to nRT over P. N is 0.03 mole and R is 0.082 liter ATM per mole Kelvin. T is 27 Celsius, which is 300 Kelvin. And P is 0.9675 atm that we calculated earlier, and that should give us 0.76 liter, and that is the answer. So the volume of oxygen gas is 0.76 liter.